Hello guys, welcome back to my YouTube channel. So today we are going to solve day 27 problem of this month on LeetCode. I hope that you guys are also solving one question daily, right? So now without any delay, let's get started with day 27 problem. But before solving it, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now let's read the problem statement first. So in this problem we have given the root of a binary tree and we have to return the length of the diameter of the tree. Okay, and the diameter of a binary tree is the length of the longest path between any two nodes in a tree, and the path may or may not pass through the root. Okay, and the length of the path between two nodes is represented by the number of edges between them. Okay, so now let's understand this with an example here. So this is one tree given to us, and what is the longest path between one node to the other node? Okay, so here if we follow this path, okay, so one edge is this one edge is this one, and one edge is this one. Okay, so what is the output in that case? The output is nothing but 3, right? If we follow this path, first I follow this path from 5 to 2, then I reach from 2 to 1, then from 1 I reach 3. Then what is the longest path? 3. So there are total 2 possibilities. Okay, so 3 is the length of the path if we follow this 4 to 1 3 or 5 to 1 3. So we have to just return the longest path. Longest path is nothing but the number of the edges between two nodes. Okay, so I hope this is clear. So now let's understand how we are going to solve this problem. Okay, so first let's say if there is only one single root in my problem. So let's say this is the root. Okay, if this is the root, okay, let's say I am here and this is my root. Okay, and this is my root. Okay, so now first I'm going to check for the left depth of this root. So I go to this, okay, I go to the left side of this root node, and I am going to check what is the depth of my root in the left side. So here there is null. Okay, there is nothing. So from here I am going to return what? 0. Okay, so here I am going to return 0 because there is nothing in my left side. Again I am going to check for the root dot right. Okay, when I check for the root dot right, again I encounter null. There is nothing here. So in this case also I am going to return 0. Okay, so here I have returned 0. Okay, so this is the case for this root when this is the root. Let's say if this is our root. Okay, so here let me write it. It is the left and it is the right. Okay, this is the right. Okay, when this 5 is my root, okay, when this 5 is my root, then what are the scenarios? When I go to the left of this root, so in the left side I encounter a null, so I am going to return nothing but 0 here. So this is my left. Okay, for this one, left is equal to 0. And then I go to the right of this root node and I encounter nothing, null. Okay, so again I am going to return 0. So this is the right of 0. So here I am just counting the left and right depth. Okay, so this is clear for you guys. When my left on the right of a root node is null, then I am going to just return 0. Okay, so here I am returning left as 0. So now let's suppose this is tree given to me. This is a tree given to me, right? So now let's suppose this is my root. Okay, now this is my root. If this is my root, then there are total 2 possibilities. Okay, there are total 2 possibilities. If this is bigger, okay, this and this is bigger, if I follow this path, or if I follow this path, I go to 2 to 4 and then I check for the right of 4. Okay, there are total 2 possibilities. One possibility is if I go from 2 to 4 and then check for the 4's dot left. Okay, or if I go from 2 to 4 and then check for the right. In this case we know that both are null, but 2 doesn't know it. Okay, 2 doesn't have any idea which is maximum. and 2 needs the maximum value for its left. Okay, 2 needs the maximum value for its left. So 2 goes to 4, then it will check for the left. 2 go to 4, then it is going to check for the right, because 2 needs the maximum value here for its left. Okay, so what is going to happen here? So now for 2 I am just going to return 1 plus max of my left or right depth. Okay, why I am taking 1 here? Because this path is common now. This path is common. 2 is going to 4 always. Okay, and after 4 it is going to check which is the maximum path, whether my left is the maximum or right is maximum. Okay, so in this case, for this particular 2, when I am at 2, so my left is going to return nothing but 1. Why? So let's apply this formula, 1 plus max of L comma R. So L comma R for this 4. So L comma R both are 0, right? Both are 0 in this case, and I am just adding this 1 common edge. Okay, so here for the left side I am returning nothing but 1. Okay, left side I am returning nothing but 1 here. Okay, so this is the left for this 2. Now check for the right of this 2. Okay, so right of 2, again there are total 2 possibilities. Okay, 2 needs to have the maximum path, so he is going to 5, and after that he needs the maximum. So there are total 2 possibilities from 5, whether he can pick the left side of this 5 or right side of the 5. Okay, there are total 2 possibilities. So now what I'm going to do, again I'm going to use the same formula, 1 plus max of left comma right. So max of left comma right is for this 5. Okay, so here again I am going to get right as 1. Okay, right is 1. Right is 1. Okay, right is 1. So this is clear. Now let's check for this 3. So for this 3, my left and right both are null, right? Left and right both are null. So it is going to return nothing but 0 initially, right? 0 initially. Okay, this is clear. So here, okay, so this is clear. Left and right both are going to return 0. Now in the final case, I am at this location. This is my route finally. Okay, this is my route. So I have to return the maximum edges, right? Maximum path, length of the path, maximum path. So here total 2 possibilities, right? Here for the left side, this one, this is the route, so it is going to call for this. There are total 2 possibilities. So one path is this one. So here one path is this one, 1 to 2, then 4, then it's to left, or this is the path, 1 to 2, then it's right. Okay, this is the path, right? For 1, this is the path. Okay, so for this again I am going to get 1 plus max of my left and right. So for 2 we know the maximum path, so in its left, 2's left maximum path is 1 left, and 2's right maximum path is 1 only. So 1 plus 1 is nothing but 2. So here I am returning 2. Okay, this is my left of route 1 when my route is 1. And here for right, there are total 2 possibilities, this way or this way, and this way, this to 3, and then to right. Okay, so this is common. So 1 plus, what is the max of left and right? So left and right both are 0 for 3, so nothing, 1 plus 0 is 1. Okay, so this is nothing but output is 1 for my right. Okay, so in the end I am going to just return, in the end I am going to return max, I am going to return the depth. Okay, so depth is nothing going to be, it's going to be only my max of left and right, right? So left is 2 and right is 1. Okay, so my output is going to be 3. Okay, so I hope that you guys are clear how I'm going to get the diameter or length, right? So now I'm going to write the code using the same story that I have explained here. Okay, so here this is a method given to us, public int diameter of binary tree. So here initially let's say diameter is 0, diameter is equal to 0, and then After that I am going to call one method to calculate the depth. So I have depth of root. Okay, whatever my root is, I'm going to get the depth of that root, and in the end I have to return the diameter. That's it. Okay, this is done. Now let's explain this method depth. Okay, so private int depth node root. Okay, so if my root, okay, let's say here, let's take a node. Okay, if my node is null, then in that case I have to just return 0, right? If node is null, then return 0. And for the left depth, I need to check like this: left depth. Again, call this function depth for the root dot left, and right depth, call this function depth of root dot right. Okay, this is done. Then diameter is going to be nothing but math dot max of my initial diameter, whatever it is there, and the left depth plus right depth. Okay, and in the end I have to return 1 plus math dot max of left depth plus right depth. Okay, whatever the maximum left depth comma right depth. Okay, so now let's run our code and see if there are any issues with the code. Okay, so we didn't initialize it. Let's write it here in diameter. We are going node by node, so let's skip here node dot left, node dot right. So all the test cases has been accepted. Now let's submit our code. So our solution is accepted, and runtime is 0 millisecond, and it beats 100% of users with Java. So I hope that you guys are able to understand today's problem. Okay, if you guys still have any question, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you in the next video. Thank you.